All right, here we are again with Mr. Briggs. We're starting a whole new unit. We're doing unit number 7, which is all about ratios and solving ratio problems. Now, ratios are one of those things that are a lot like fractions. They're like super fractions. Um, Ratios are basically a way of showing in a number the relationship between two different things. Now, we use ratios all the time. We use it for miles per gallon. We use it for recipes. You need so many cups of milk for every cup of flour. We use it for cars, air to fuel ratio, miles per hour, all kinds of stuff. It's great. But it does get people tricked up because the way we can write ratios is different from how we write fractions. They're sort of similar, but different because we can write a ratio just like a fraction. Let me show you what I mean. We have these three problems. Write each ratio three different ways. And my first one here is legs to eyes on an octopus. So legs to eyes on an octopus. Well, there's several ways I can do that. I can do 8 written out to 8 to 2, right? There's 8 legs for every 2 eyes on an octopus. Or I can use an 8 and a mathematical symbol called a colon here, 8 to 2. And that is another way of writing a ratio. Or you may have figured this out already, and this will lead to how we solve a lot of really neat problems, is I can also rewrite this as a fraction. 8 over 2. Okay? Either way, it shows a relationship of 8 to 2. 8 legs for every 2 eyes. So if there are 4 eyes looking up at me from an aquarium full of octopuses, I know there are going to be 16 legs in there. All right. That's our first example. Let's do a few more. Our next example is wheels to headlights on a car. Well, how many wheels are on a car? Well, I don't know about you, but my car has 4 wheels. Now, some of you are going to argue with me because, again, you're farm kids, and you're going to say, oh, our car has so many. You know what? 4 wheels, most cars, 4 wheels. 4 wheels, 2 headlights. Now, I could get really stingy here and say, oh, I've got high beams or fog lights. But again, generic car, 4 wheels for every 2 headlights. Now, once again, I can rewrite that 2 different ways. How can I rewrite that? I can rewrite it as 8. Oh, sorry, thinking octopuses again. 4 colon 2. Or, once again, any ratio can be rewritten as a fraction of 4 over 2. Now, here's the fun part. I can solve some problems by rewriting that 4-2 the way I rewrite any fraction. I can rewrite it as simplified, okay, 2 to 1. There's a 2 to 1 ratio between between wheels and headlights. More on that a little bit later. Okay? My next one, my last one before we start getting into problems, is, okay, get rid of that one, 15 students for every 3 teachers. How do I rewrite that? Well, you probably know it already. Go ahead and write them down if you know them. I'll give you a minute. I can write it as 15 to 3 written out. I can write it as 15 colon 3, 15 to 3 ratio. Or I can write it as 15 over 3, as long as I understand that it is students over teachers. Now, I could then ask myself a question, and that maybe leads me into the next little thing we're going to do. How many students are there per teacher? Now, I could do 15 per 3, but that doesn't sound as good. Can I simplify this so I only have 1 teacher? Can I make it so that I have a 1 on the bottom? Yes, I can, because I can divide 15 and 3 by 3. If I do 3 divided by 3, I get 1. 15 divided by 3, I get 5. So there are 5, okay, students for every teacher. That's where the simplification thing works out. Okay? We use simplified fractions all of the time. Think of miles per gallon. All it is a simplified fraction, or a simplified ratio. Let's do a problem now that is completely different from all of these. Clean up my board here. Mr. Briggs's awesome car. Notice awesome is capitalized because that's what it is. It is the awesome car. It gets 38 miles to every gallon. If he buys 8 gallons of gas, how far can he go? Well, I'm going to write this out as a fraction because that is the easiest way to solve these ratio problems. 38 over, okay, 38 over 1 because I have miles on the top and I have gallons on the bottom. I can get 38 miles for every 1 gallon, right? And I'm going to set up my problem. 38 miles to the gallon. And whatever I end up with, I've got to make something that equals. Okay, it has the same value, but it has an 8 on the bottom. Okay, I don't know what my distance is. So, what times 1 gives me 8? 1 times 8 gives me 8. So, if 8 is on the bottom, I need to have 8 on the top as well because this is a multiplication problem. It is an equality problem. So, in order to solve for n, I need to do 38 times 8 so that this fraction can be true. How far can I go on 8 gallons? Well, 8 times 8 is 64. That's right. 8 times 3 is 24 plus 6, okay, gives me 30. So I can go 304 miles. And I'm going to invoke the Kessler rule. And the Kessler rule says we have to label everything. 304 miles. All right. That is how we solve a ratio problem. Keep this in mind when we work a little bit farther in this chapter. Okay? This is a very simple example, and it pays to draw a picture or to organize your ideas. All right. Here, ladies and gentlemen, are your questions that you need to answer before I will let you continue. A drama club has 14 females and 8 males. Write each ratio 3 ways. Males to females, females to males. Now, this is one problem. Okay, so you'll need to come up with 3 different examples here. And 3 different examples for the one below it. Now, 3 and 4 are 2 separate problems. Okay? We have to write 2 different ratios equivalent to 4 to 8, and I want you to write ratios in simplest form. Which ratios? I want you to write 8/12 in simplest form, and I would like you to write 10 to the 6th. 10 to 6 in simplest form. Remember, you can rewrite 10 to 6 as a fraction. How do you do that? Well, if I told you, I'd be solving half of this problem. So here again are your 4 sort of 5 problems. Go ahead and show these to me when you are done.